Welcome, everybody. This is the Dissertation Power Hour. It's really just a half an hour, but you know what? I'll go as long as you guys want to hang out. And we're going to talk about the most important thing in the quantitative dissertation is you need to define your variables. Okay, so personal experience, been with the line for about 20 years, been working on dissertations for about the last 15 years. I'm not supposed to, but I do anyway. So this is the number one thing that I feel will make it a lot easier on you quantitative dissertation writers. If you know what your variables are, and I'm going to explain it as we go. If you know what your variables are and you have your hypothesis question ready, then there's absolutely no question on which test that you need to run. Okay, it's all very structured, very functional. Okay, so and this is for quantitative dissertations. I'm not an expert at qualitative. I've seen a lot of really great ones, but again, if it doesn't have numbers in it, I can't help you. So quantitative means numbers. So first of all, what are your variables? What are you measuring? Okay. And a lot of people, we have special things. We have demographics. Everybody does demographics, which is fine. So demographics are gender, age, how much money you make, how much schooling you've had, et cetera, et cetera. So everybody does those variables. And then other people do, they collect information using surveys, which again, the results of those surveys are another variable. So variables can come in. There's three different types of variables that we're going to talk about today. And just remember, a variable is a measurement. Something is being measured in somebody. So it changes in value from person to person. It's a characteristic. It's something about somebody or something that can change in value from subject to subject to subject. You know, height, weight, depression scores, the type of business they do, just anything and everything, right? Because we're all different somehow, some way. So there are only three types of variables. Actually, there's a fourth one, but I'll explain it here in a second. Three types of variables that you need to know. And here's three good examples. Age, how old the subject is, what their gender is, and other variables that you're going to use a Likert scale to measure. And a Likert scale is a typical one is 1 to 5. 1, I hate it. 5, I love it. 3, I'm kind of neutral in. But that's what we call a Likert scale. Very commonly used. So age is what we call a continuous variable. The word continuous comes from calculus. All that means is you can have fractions. Seriously, that's what a continuous variable means. You can have fractions, you can have decimals, et cetera, et cetera. And it's also called a scale variable in SPSS. How many of you guys are SPSS experts? Don't rush, okay. No worries. Everything you need to do in SPSS, I got 10 videos on everything. I'm going to show you this at the very end here, okay? But so things like age, weight, IQ scores, anything that can have a decimal is considered a continuous variable. All right, coming up is gender. Gender is a nominal variable, also called a categorical variable. I tend to use the word categorical because it makes more sense. But it puts objects, people, things in specific categories, right? Like a person's eye color, like, which program they're in, what do they do for a living, where a number really doesn't make any sense. So the most popular one is gender, right? It's a categorical variable. Most of your subjects will either check male or female, and we arbitrarily assign them number values. So like a 1 would be female and a 2 would be male, or vice versa, or something like that. But that's a nominal variable. The last one is a Likert scale. And it normally goes 1 to 5, 1 to 7, 1 to 10, anything like that. But it kind of makes sense. It's a ranking order kind of thing. And again, with the Likert scale, 1 is strongly disagree, 5 is strongly agree. Very important here. I've dealt with too many people, they get this thing backwards, right? So like say the survey, you're trying to measure how much they like chocolate ice cream. And they'll put 1, I love it. 2, I like it. 3, I've got a neutral. 4, I don't like it. 5, I hate it. That's backwards, you guys. Because when you think about it, if you put this stuff into a bar graph, what that would mean is the smaller the bar graph, the more they like chocolate ice cream. And it's just the opposite of what you're trying to measure. So whatever the positive is should be your 5. Whatever the negative is should be your 1. Okay, hold on a second, you guys. Didn't come back this time, sorry. And now for the next show. So Likert scales are called ordinal. Ordinal variables are actually pretty cool, okay? They're somewhere in between a continuous variable and a gender and a nominal variable, categorical variable. But they don't have any fractions or decimals, but it can be used both as a continuous variable and as a categorical variable. That's the beauty about the ordinal variables. They're very, very utile, right? You can use them anywhere and everywhere with one little sidebar. If your data is in the ordinal form, we're supposed to use the non-parametric versions of the t-test, of the ANOVA, and of the difference tests, right? So just remember that if your data is ordinal, you're going to use the non-parametric version of a test, which is no big deal, okay? Also called rank. Now, my favorite Likert example is military rank. So the private is a 1, the corporal is a 2, the sergeant is a 3, right? So the higher the number, the more authority that these people have. So that's a perfect example of an ordinal variable. And then usually your level of education is an ordinal, or your level of SES. Anything with the word level in it is going to be a Likert scale. Okay, so those are your 3 variable types: continuous, nominal, ordinal. And this is where I talk about the 4th one. It's called interval data. And I'm going to go on a little rant here. You know, they teach it to you. You have to memorize it in a class, and they test you on it. But honest to gosh, you guys, I've worked on over 1,000 dissertations, and I've never seen it used once. And the only example in every of my 17 books that I've read that they have for interval data is the same one. It's temperature. And all it really means is a 0 doesn't make any sense in interval data. And they always have the same example. When it's 0 degrees outside, that just means it's really cold. Okay. It doesn't mean there's no degrees outside. It just means it's really, really cold. So that's how you interpret interval data. And I'm just going to flat out say, don't use it. Don't use it. Me. All right, continuous data. A lot of, right, this is how you tell. If you're looking at a list of numbers, that's a variable, right? In an Excel spreadsheet, you're looking at a column of numbers. That is a single variable with a range of measurements in there. And if it goes from like 2 to 67 or something, that's a continuous variable, whether it has decimals or not. So if the spread of the data is big enough, just treat it like a continuous variable, okay? So all of these age, height, weight, assessment scores, annual salary, just basically, again, if you got a big range of the numbers, just call it a continuous variable. And coming up next is nominal data. Now, that's a grouping variable, right? It's a partitioning variable. And be careful, because I've run across people that they have 15 different subgroups in a single variable. and a subgroup in a nominal variable is called a level. So usually, like ethnicity, you can have 6 or 7, right? White, African American, Hispanic, Asian American, Middle Eastern, the Polynesian Islands, other, right? So don't go crazy on the number of categories or the number of levels for a categorical variable, because the tests that you're going to run, like the ANOVA and everything, there are limits. And the more levels you have, the more categories you have, the more likely you are of going to make a type 1 error, and you don't want to do that. But it deals with independent groups. So if somebody's in group A, they're not in group B, okay? Make sure there's no overlap between the groups. That really screws everything up. You don't want to do that. But again, here's the most used ones, right? Gender, ethnicity, profession, type of therapy, car color, et cetera, et cetera. All right, moving on. Ordinal data. So again, when you see the word levels, you're probably dealing with an ordinal piece of data. And the most common one is high, medium, and low. Or low, medium, and high, whichever way you want to go is fine. Now, here's the beauty about an ordinal data. You can take any variable, like let's take annual salary. And you have the people's physical salaries in there, right? And you get this long range of numbers, so it's really a continuous variable. But you, as the researcher, you can make cutoffs. You could say anybody that makes under, $25,000 a year is low, between 25 and 75,000 is medium, above 75 is high. So you, as the researcher, can turn a continuous variable into an ordinal variable, which in turn can be turned into a categorical variable. So there's a little bit of juggling there. It really depends on what your question is, right? So Likert scales, levels of SES, work position, right? Staff were the low guys, and then you got the management and you got the executoids. So, it's again, if you could feel a characteristic increasing with each step, that makes it an ordinal data. Just remember, ordinal data, the larger the number, the stronger the characteristic. Or I had to use the word characteristic because there's a lot of different applications that can be put here, okay? Just remember, the higher the number, the higher whatever it is you're counting in that one person or subject. All right, so why are you going to identify these guys? Simply because. Inferential statistics, that's the one where you do stats, okay? So descriptive statistics is the bars or the bar graphs and, the pie charts and anything that looks like a picture, right? That's a descriptive statistic. But in inferential statistics, that's when you have to study all this stuff in school and reject the null, et cetera, et cetera. But very important, I'm going to teach you all of my 20 years in statistics experience in one sentence. Me. Everything you do in statistics is one of two things. You're either looking for a significant difference between groups, actually between group means, or you're looking for a significant relationship between two or more variables. Say that again. You're either looking for significant differences between group means or significant relationships between variables. Now, the second part is a cause and effect, okay? But we're not supposed to say cause and effect, but I use it all the time. So differences, right? Example, do men have significantly higher annual salaries than women? So you got to break down what your variables are, right? So for this question, get back in there. The difference in the DV, that's your salaries, right? Because everybody, men and women, they measure their salaries. Whatever's measured in everybody, regardless of groups, is your DV, okay? So this one, in this example, the DV would be your annual salaries between the levels of the IV. The IV is gender with 2 levels, men and women. Anybody know what test this would be? This would be an independent t-test. Didn't know I was going to quiz you on this, did you? but remember, when you work, big help. When you see the word difference, okay, it's either going to be a t-test or an ANOVA. That's all there is. Say that again. When you see the word difference, it's either going to be a t-test or one of the ANOVAs, because that's what they do. They look for differences in group means. All right, another example. You were looking for anxiety scores. That's the DV. Everybody in the study is being measured on how anxious they are. But this time you got 3 groups, 3 levels of psychotherapies. Even though it's only one IV named psychotherapy, it has 3 subgroups or 3 levels. And we'll just call it CBT, ABC, DEF. I don't know, I'm not a psychologist. Okay. So again, you see the word difference. And if there's more than 2 groups, in this one there's 3, it's got to be an ANOVA. One way between group ANOVA. Now the ANOVA family goes on and on and on. There's literally about 10 different kinds of ANOVAs, but they all work like the first one. Okay, they're looking at the means of the different groups and comparing them. That's all there is to it. Okay. Here we go, relations. Does a change in one variable cause another variable to change too? Right? I say cause and effect. Some of my teacher buddies always yell at me and say, you're not supposed to say that, but you know what I mean, right? Cause and effect. So a good example is the more hours I work, the bigger my paycheck will be, right? One thing is causing the other thing. It's kind of like a domino theory, okay? And that's a relationship. Does an increase in daytime temperature cause an increase in ice cream sales, right? So you actually got 2 variables in this example. One, it's a continuous number, right? Daytime temperatures, because every day it could get hotter, it could get colder, right? So it changes from day to day. And ice cream sales, same thing, right? Some days they sell a lot of ice cream, some days they don't. So this is the question. Is there a relationship between daytime temperatures and ice cream sales? Of course there is. And that would be a correlation, right? The word relation is right in that, right? Is right in correlation. And co means 2. Or a simple regression, okay? So backing up here, the ANOVA is built on the t-test. The t-test, believe it or not, is the granddaddy of all of these statistical analysis. All started with the t-test. And then coming up next was the correlation. So all the ANOVAs use t-tests. All regressions use correlations. And that's it. That's all there is for statistics. Everything's either a t-test or a correlation. And then a correlation is when you got one variable affecting another variable, right? There's only 2 variables involved. Simple regression, it's the same way. It's minorly different, but a simple regression also gives you something we call effect size, which is the percent of the variance that you can explain. But then multiple regression is the money ball there. That's the one where you have multiple predictors of one DV. This is the most used one right here, multiple regressions. It's like the hammer in your toolbox. It'd probably be the most used tool that you guys use is multiple regression. And then I had to throw this one in here because associations are what we call the results of the chi-squared test. Okay, a chi-squared test, all it does is it looks at two categorical variables. Right, this is the weird part. Categorical A, categorical variable B, right? You got two categorical variables. So let's take gender, right? Everybody's male or female. And let's take political party. And let's just say Republicans, Democrats, other. So a chi-squared test would look at that relation. I used to call it a relationship because it is a relationship. But in the last 5 years, the book say association. So if one, I'm just going to give you the example. The Republican Party tends to be male. Okay, that is a finding from a chi-squared test. Republican Party, that's one level of the political party, and male, that's one level of the gender variable. So when those two intersect and the count numbers are so high or so low to be considered significantly different, that's what we call a significant association. Right, do men tend to belong to the Republican Party. Does anybody know about this? Has anybody ever checked the numbers? It's true, right? Men, the Republican Party is made up of males and not just males, right? But the statisticians know all of this. Like Hispanics tend to vote Democratic. So when it comes to their marketing and advertising, they will hit the Hispanic areas, right? Because they know that historically Hispanics tend to vote for the Democratic Congress. And this is called the chi-square test of independence. So define your variables, and I misspelled it. I'm going to fix it right now. So I got a good excuse. I misspell all the time. But I'm a numbers guy. I don't need to know language. Language is not my strong point, as you could probably figure that out already. Okay, that was it. Now, I'm hoping everybody here knows where to find all this stuff. Everything we've done. Let me give you the $2 tour here, you guys. Everything we've done, you can find right here. Stupid Zoom. Can you guys see this now? Good. All right. So this is our portal page, and I am in the middle of transferring all the Moodle stuff. That's where we put all our stat support, writing support, dissertation support. We've been using Moodles, but they're getting rid of Moodles, so we're transferring over to the SharePoint. And by we, I mean me. And then this is what I've been working on. And I believe it's functional. Okay. So everything that we have in a dissertation toolbox is here, right? Different power hour presentations. So this power hour presentations will line up on this one. The ones that are upcoming is here. And then we got a ton of APA support, Qualtrics support, IRB support. The statistics one, it will be up and running during the summer. That's going to take forever. That's the big one. But the rest of this stuff I should have done in like a week or two. Okay. So I want you to check that out. But The Moodle pages is where everything is and everything works. The videos work. And so here's the dissertation toolbox. To get here, simply go to your Alliant Moodle page, and there's a little tiny search box. Scroll all the way down to the bottom. It's a little tiny search box. Type in the word Hawk, and all the Hawk Moodles, the Hawk Moodles are the tutoring Moodles. They'll all show up at the same time. But this is where everything is. And the old videos are there. The new videos are there. The links to the statistics are there. APA formatting, everything. Literature view, research in the library. Scott made us a bunch of cool videos. And most of these are videos. Qualtrics, Excel, IRB. Oh my God, the IRB. God have mercy on your soul. You know, and some punch-up stuff. But this is where the big stuff is. So that's about it in a nutshell. Now, since you guys showed up, if you get stuck, email me, all right? I'm not supposed to help with dissertations, but I do. You know, I'm getting close to retirement, and I really enjoy working with you guys because you're hardworking people, right? So the dissertation, I got nothing but respect for, because, you know, you guys have been going to school for like 25 years. 25 years you've been going to school, and your dissertation is supposed to be the absolute best thing that you've ever done in your 25 years of school, right? And I'll be honest with you, usually I'm very, very impressed. I mean, you guys do a heck of a job. I mean, and you get published, and you go get great jobs and become famous, and, you know, buy fancy cars, and you forget all about me. Just kidding. All right, let's wind this up. Any burning questions or anything? And
just a thank you very much, Dr. Gardner. I'm sorry I have another meeting, but this was extremely helpful. You make it very dummy proof, and I look forward to seeing the rest of your resources. So
you are quite welcome. Thank you for the kind words. And you guys, again, you know how to get a hold of me. I'm all over the website. Just go to the Academic Support Center. You'll see me all over the place. So.
Does that extend? Because I'm actually part-time faculty, and I'm helping students with their dissertations. Does your request to consult extend to part-time faculty too?
Certainly.
Oh, thank you so much, Dr. Gardner. You'll be hearing from me, and good luck to everyone else on your research. You can do it.
You can do it. Yeah,
I'm an alum, so there's a light at the end of the tunnel. Good luck.
There is.
Okay.
Thank you.
All right. You're welcome, everybody, and peace out.
Thank you.
Bye.